Hello everyone and welcome to our tutorial about kinematics and p5.js. And in this tutorial we're going to be building this thing, and this is just a bouncing ball that's going to be bouncing, and it's going to be bouncing around and it looks kind of cool, and we're going to build it using p5.js. So let's take a look at how this works. So in kinematics, how objects move is when an object falls, it's going to have a displacement, it's a velocity, and its acceleration. And displacement just means pretty much just the object's position relative to where it started. And we're going to have a velocity. This velocity variable is going to be constantly added to the displacement or to the object's position. And then the acceleration, and the acceleration on Earth is negative 9.81 meters per second squared. And what acceleration is, it's basically just the rate of change of the velocity. So the slope of this velocity is basically negative 9.81 because that's the acceleration. And yeah, that's basically how it works. So we're just going to have a constantly decreasing velocity that's constantly added to our player's position or our little box's position, and able to get this cool little animation thing. So let's just build that. Okay, so first of all, we might want to start off with some variables. So I'm just going to say var player position equals, and we're going to make this a vector, and this is an object, by the way. So we're going to have an object with key x starting at initial position 0 and then a y position of 0. Or actually, let's make this yeah, let's just keep it at 0 for now. And then here in draw okay, by the way, the start function is called at the very start, and at the start it's going to create a canvas, which is this. This is our canvas, and this create canvas function takes in the two parameters. This is the width of the canvas. This is the height of the canvas. And then we're going to see another function here called draw, and this function is basically going to be called every single frame by p5.js. And what it's going to do is it's going to create this background. It's going to basically just clear the canvas every single frame, essentially. So what we can do is we can just write our code under here, and then it'll do whatever it does every single frame, and it'll clear it again, and it'll do whatever it does here. So one thing we can do to draw our player is call the rect function, and this rect just calls a rectangle. It creates a rectangle at position x comma y, and then width comma height, and that's just the parameters. So we can just say player position dot x, player position dot y, and maybe a width and height of, say, 50. And if we run this, we can see we have a square that's been rendered on the top of our screen, of our little canvas. So what if I want this at the center? If I want to put this at the center, maybe I'll position it at 200, 200. And now this tip is at the center, but I actually want the whole thing at the center. So what I can do is I can set rect mode center. And what this does is just creates, whenever it creates a rectangle, it'll just set it to the center. And there you go, now the rectangle is at the center. Okay, now we can start implementing some of these kinematic stuff. So we can see here, we already have our player position, so we already did this. Now we just need to add velocity and acceleration. So var velocity. And then we're going to make this a vector again. So we're going to have an initial velocity of 0, 0. So there's an x component and a y component to our player's acceleration. And finally, we're going to have acceleration equals, let's just say 1. Okay, so it's not 9.81 but I'm going to explain that later. But for now, let's leave it at 1, and maybe we can tweak it later. So as you can see here, since acceleration is being constantly added to our, or we can actually make acceleration negative, and then we can constantly add this to our velocity, or y component of our velocity. We can do that inside our update function. So every frame, it's going to be velocity dot y plus equals acceleration. E-R-A-T-I-O-N. Okay. And now that we did that, our velocity is going to be constantly added to our player's position. So we can say player position dot x plus equals player, or not player, velocity dot x, and then player position dot y plus equals velocity dot y. And we can just add those two vectors up, and then we should get something that falls, hopefully. Or it falls the other way, because, okay, what did I do? Alright, maybe not -1, and then it should fall the other way. Yep, and now it falls down. And 1 seems like a little bit much, or actually, we can just do 0.5, we set acceleration smaller, you can see it falls a bit slower, or the rate of acceleration, or the rate of the change of the velocity is much slower. So yeah, now we have a falling cube. But say, what if we actually wanted to bounce up and down like this one? How do we do that? Well, how we can do that is actually, when we can just detect collision by saying, like, if the player's position or the bottom of the player cube is at or below the bottom of our screen, then we can basically just set our velocity back up to 0, or back up to another value that's higher than 0, and then it will bounce back up. So let's try that and see what happens. Alright, so what we can do is we can have an if statement to check if the player collides with the bottom here, with the bottom of the screen. And what we can do is we can have an if statement here. So we have to say if player position dot y, and then we can account for the fact that the position of the player is at the center, so we can subtract, or we can add 25 to that, since that's half of our player's width or height. And then we can compare that, since our screen is 400 pixels high, and actually in p5.js, the coordinate system actually works as 400 would be at the bottom. The y position of 400 would be at the bottom. So we can say if it's greater than 400. So if it's greater than 400, then what we can do is we can actually set our velocity dot y to something like -10. And if we run this, it works, and it jumps up and down just like we want it to. And the reason why this is working is because, yeah, as you can see this example, as velocity is set to some higher value, like here, that's above 0. So initially what we were doing when it was just falling, it's actually just here. The velocity started out at 0, and it was constantly decelerating, or constantly accelerating at a negative direction, -9.81 here. And then that's what this was. This is the displacement over time that the object was falling, right? And then here, if we set the velocity to something that's greater than 0, and then we let it continue downwards, we're going to get something like this. We're going to get this curve. So that's exactly what's happening here. This thing is jumping upwards, and yeah, that's basically what's happening right here when we set the velocity to some random positive value. It's going to continue upwards until the velocity is 0, and it's going to continue downwards until it goes down and jumps back up. So what else could we do with this? Another thing we can do is we can make this go left and right, and we can just make that constant. We don't need acceleration for that because there's no gravity involved in that. So let's just do that. So we already have a velocity variable. It's already being added here. So all we really need to do is say, we can just say velocity x sets to maybe like 5 or something. And you can see it starts moving at that exact rate. And it's a bit too fast, so I'll slow it down. And then what we can do is we can do the same collision detection thing, except with the left and right walls. So all we need is a couple more if statements here. So if player position dot x, and then let me think, plus 25 is greater than the width, which is 400. Then we can set velocity to maybe -2, so that way it goes to the other direction. And then else if player position dot x plus 20, okay, not that, but minus 25 is less than 0, so it's on that side of the screen, then we can set velocity back to 2, or velocity.x, actually. And let's try that out. And yeah, it bounces back and forth just as we'd expect. And yeah, that's basically it for this video. And another thing to note out is actually in the real world, if you bounce a ball on the ground or a box on the ground, obviously it's not actually going to behave like this because it's going to lose some of its energy. So an important thing to note is that this is an example of a perfectly elastic collision where all the energy is actually like restored, or it's not restored, but it's like not no energy is lost. So it bounces back up to the initial position. But obviously in the real world, it won't happen. It will probably decrease over time, the height of in which it bounces. But since this is perfectly elastic and there's no kind of like friction or like air friction or anything, then it perfectly bounces up and down. And it will never stop and it'll just keep going like this. So that's just a cool simulation here. We learned a lot about programming in JavaScript and using p5.js library, as well as a little bit of physics and kinematics. And that's pretty much it. Thank you for watching, guys.